TechWiz Polar is optimized in analyzing the polarization states according to the phase retardation of each layer. Let's check the TechWiz Polar. Please double-click it. The first thing to do is to create a project file. Please enter the name as TN and set the folder to be saved. Also, it is possible to load the previous saved file which is used in the TechWiz 1D. So you can utilize the 1D project file in the TechWiz Polar. From now on, to check the simple TN result, please drag and drop the TN group layer. If you want to change the properties of a layer, please double-click it. For example, let's double-click the LC layer. The window is the same as TechWiz DB. You can change the refractive indices or optical axis and check the lobbing condition. You can set the polarization state of the incident light and type. When the Stokes vector is selected, the S0, S1, S2, and S3 values are activated, and the polarization state of the incident light can be set as the Stokes parameter. If you select Jones, you can adjust the EX, EY, and phase difference of the incident light. You can also select a predefined polarization state in the predefined window. If you click this animation button, you can check the polarization of the incident light in the form of a video. You can also set the wavelengths and viewing angle conditions. I already mentioned about the method of setting conditions in TechWiz 1D, so let's set the conditions. For the wavelengths, let's check the RGB3 conditions. Please enter like this. And for the viewing angle conditions, set the theta at 10-degree intervals and phi at 15-degree intervals. Every condition is complete, so let's click this Run button. When calculation is complete, Polar Viewer automatically appears. If you click the tile window, 4 results can be checked on one screen. Let's check the transmittance first. It is the transmittance result in the form of a polar chart. Result can be checked according to wavelengths and viewing angle conditions. Since the initial state of TN is a normally white structure, it shows a white state. If you click the Transmittance tab at the bottom, there are some options, so please utilize them. And the next one is retardance. Click Line and check the retardance for each layer in layer information. It is the retardance of the bottom polarizer. Since retardance is calculated by delta ND equation, the retardance of isotropic materials is 0. Please check the refractive indices of the polarizer. NE and NO are the same as 1.5, but imaginary parts are different. If you click the data table, you can see that it is not a perfect zero. And in the case of the LC layer, since it is anisotropic, it has the following retardance. And if you click this polarization ellipse, it shows the retardance in each viewing angle direction. Click the E-field wave tab. Polarization can be checked in the form of electric field waves. If you click each layer defined in layer information, you can check the polarization of the layer as an electric field wave. Through the low data, you can check the Stokes parameter, EX, EY, and phase difference of the layer. If you right-click on the screen and select ellipse view, you can see the electric field wave from the front. Finally, click on the Poincare sphere tab. The polarization of the 1D structure can be analyzed through the Poincare sphere. S1 is horizontal and vertical linear polarization. S2 is 45 and minus 45 degree linear polarization, and S3 is a circular polarization. So, let's check from the bottom polarizer. Please look at this red point. Since the absorption axis is minus 45 degrees, the transmission axis is 45 degrees. So it is located at this position. The next layer is isotropic, so there is no polarization change. Since the LC layer is a half wave plate, it changes as follows. However, delta ND equals lambda divided by 2 equation is not clearly satisfied, so it is placed in this position. Again, since the layer is isotropic, there is no polarization change. Lastly, top polarizer changes as follows. So, we checked all of the results. Let's go back to the program. If you look at LCD type, there are two types. We checked the results using the transmissive type, and let's check the reflective type. I will show you some figures about the reflective type. 1D structure is defined in the stack list and select reflective type. As a result, the internal solver automatically performs the calculation as a meter type. So there is no need to define a reflector. And the next one is real-time tab. In this tab, polarization analysis can be checked in a real-time condition using Poincare sphere. Define the input light, wavelengths, and viewing angle conditions. For example, if you want to check the real-time polarization analysis according to the LC thickness change, please double-click the LC layer and change the thickness. For example, I changed the thickness as 4.6, so you can check the result automatically. So until now, I have explained about the TechWiz Pola.